All right, good morning, grade 7 and 8s. Welcome back. We are going to continue our talks about decimals. Yesterday, we specifically talked about place value, and a big reminder from yesterday was that when we have things, for instance, if we have two different numbers, we always line up, that's supposed to be a decimal, things of the same place value. So here I have 327 and 1900ths. It's the first time that I'm allowed to say and because the decimal. Now let's say I'm making a list of numbers with decimals and I have 10 and 1/10. Well, I put the 10 here. I can't start the 1 here. I want the decimals to look like they're in the same spot. And then I have my 1s lined up, my 10s lined up, and then I said 1/10. Could I put a 0 here? Yeah, I could put as many zeros as I like, but I only need 1/10, and the tenths are lined up on top of each other, more or less. Again, dealing with rather messy writing tools on the smartboard. Then we talked about the idea of, can I make a decimal look like a different decimal? And the answer is yes. Just like fractions, there are equivalent decimals, though there aren't as many options. For instance, if I had 1/10 in fractions, that's the same as saying 10/100ths. They are the same value. They look different, but they're the same value. And I can do the same here. This is 0 and 1/10. And here I have 0 and 10/100ths. Notice that I'm referring to the hundredth column, and I'm pretending like I don't have 1/10 and 0/100ths, but as a unit, they are 10/100ths. So it is the same number looking different. However, we can do it in different ways as well, and that's what we're going to talk about today. We're going to call this regrouping decimals. So I got some questions yesterday, which was fantastic, and now I'm able to coordinate this. We're going to use the example given in the work package. You're looking at page 65. And on page 65, they suggest imagining the decimals as our base 10 blocks. So we have ones, we have tens, and we have big hundreds. And we use these for algebra when we were doing the visual version of algebra, so you should be used to these. But now, this big block is a 1. It is one whole. Now this one is a tenth. And these little guys are, hundredths. Man, that word is a pain to write with your finger on a touchscreen. Anyways, hundredth, tenth, 1. Cool. When we are doing this, you may be told that there are more than 10 tenths. For instance, if question 1 says regroup as many of the blocks as you can into bigger blocks, and it gives you the example in A where they had 10 tenths, and I can go, I don't need 10 tenths, I don't need 10 sticks. I can turn that into a whole. 10 tenths is a whole, so why do I still have them looking like tenths? And then further down that question, it had it had 17 hundredths. 2, 3, 4, 5, 6, 7. And they said the same thing. I can take these 10 hundredths and I can make them into a tenth. I don't need to keep them in the hundredth form. So that's the idea of regrouping. So I'm going to go to question 2, and it says 27 tenths. So maybe you're looking at this and you're trying to do it with numbers and not pictures. Well, I want you to think about it like adding. Remember when you do basic addition, and let's say I had 90 plus 27, well, I would add down 7, and here, well, 9 plus 2 is 11. I have 11 tens, but when I do math, I don't write 11D. I would say, okay, well, I have 1 10 here, and then I carry the 1. That 1, first of all, isn't a 1, and it's not a 10. I've admitted that I have more than 10 tens, which gives me 100. and then it goes down here. You can do the same thing if you can get your mind around it with question 2a. Question 2a says 2/7 or 27/10. Yikes, don't know where I got 2/7 from. 27/10, and it even started you off. Here it admits, okay, well, with 27/10, I have 2 1s, and then I have 7/10. We can do 2b, 74/100. 74/100. Now I could 74 times, or I can realize, okay, well, if I have more than 10 hundredths, I have a tenth, which means I have 7/10. 7 whole tenths. 70 hundredths makes 7/10. And what I have left, I have 4 hundredths. All right. So I'm going to try and find one more question. I know I had a few others that you can regroup the other way as well. You can, let's take a look at 6. Underline the smallest place value in the decimal and then write the decimal as an improper fraction. So question 6, page 66, last page, they gave us an example. So they had 2 and 3/10, and then they underlined it, went, okay, I need to make everything look like a tenth. So I have 3/10, and that means that this must mean 20/10. Well, I'm going to turn it into a fraction. Tenth is my denominator, and I've got 23 of them. All right, let's do B. B is 9 and 5/10. Well, same thing. My fraction is going to be a tenth because my smallest digit is a tenth. And I don't have 5 of them. I have 95 of them. Lastly, I'll do H. If you look at H, I've got 1 and 934 thousandths. So that 4 is our smallest digit. The thousandth is the smallest place value, which means that my fraction will be out of 1,000. And then I'm going to have 4 thousandths, of course. No, then I have 34 thousandths. I have 934 thousandths. But no, what's more is I have 1,934 thousandths. Okay, so I'm going to leave it there for regrouping. If you have more specific questions or you have a specific question, again, the page number, so I gave you page 65 and 66 today, as well as the question number is the best way to get a very immediate response. Otherwise, I'm going to continue to make generic videos like this. Thank you very much for your time, and I hope to see you soon in our meetings. Have a good day.